Work is the transfer of energy caused by a force that moves an object a distance. For example, if we push a box with a force, then the box will move as it slides along the floor. Since the force is making the box move some distance, work is being done. So in other words, an energy transfer is happening. Now in this case, the force is taking chemical energy from our hand and transferring it to kinetic energy in the box, which is why the box moves. We'll learn more about the types of energy transfers that are caused by forces elsewhere. For now, let's look at how we determine how much energy will be transferred when work is done. The amount of energy transferred to or from an object depends on the force applied and the distance the object moves. Specifically, we calculate this using the equation work done is equal to the force multiplied by the distance moved in the direction of the force, where the work done is equal to the amount of energy transferred. Also note that we only measure distances in the same or opposite direction to a force. We'll learn more about this elsewhere though. We can also write this equation in symbol form, W equals F times S, where W is the work done, F is the force doing this work, and S is the distance the object moves in the direction of the force. In your exams, you'll see the term work used to describe many different energy transfers, but you'll only need to do this calculation for simple cases of forces making an object move a measurable distance. But what units should we use for this equation? Well, first, the strength of a force is measured in newtons, then the distance is measured in meters, and since work is the amount of energy transferred, then we use units of energy for this, so joules. In fact, we use this equation to define units of energy. So 1 joule, J, is the amount of work done when a 1 Newton force moves an object by 1 meter. In other words, 1 joule is equal to 1 Newton meter. Let's look at our box example again, and suppose we apply a force of exactly 1 Newton. To push the box, exactly 1 meter. Then, by definition, we have done exactly 1 joule of work. But remember, work is not a type of energy itself. What we're measuring is the amount of energy transferred. In this case, we are taking exactly 1 joule of chemical energy from our hand and giving it to the box as 1 joule of kinetic energy. Let's try a simple example using this equation. Calculate the work done when a 5 Newton force pushes a box 12 meters in the direction of the force along a smooth table. So here it's been clarified that the distance is in the direction of the force, so we can use it in our work equation. We're also told that the table is smooth, which means there are no frictional forces affecting the motion of the box. So step 1 is to write down the key information and check the units. We're told that the force applied to the box is 5 newtons, and that it moves a distance of 12 meters. Both of these measurements are already in the standard units for the equation. So now we need to use this information to calculate the work done. Step 2 is to use the values for force and distance moved in the formula for work done, which remember is work done is equal to force multiplied by the distance moved in the direction of the force. So to calculate this work done, we multiply 5 newtons by 12 meters, giving a result of 60 joules. So 60 joules of energy was transferred by this force.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!